Step 2. Is the ratio proper? And by a proper ratio, we mean, is the greatest power of S in the denominator greater than the greatest power of S in the numerator? And if not, use long division to make it so. So again, easiest to show by an example. If we have something like s squared plus 4s plus 7 all over s plus 3. First check, is it in standard form? Yep, decreasing powers of s. Coefficient of the largest power of s is 1 over here. But it is not a proper ratio. Just to give a few more examples of proper ratio, this is squared, this is squared. So this is, although it's in the standard form, it's not in a proper ratio. It's not a proper fraction. This is 2, this is 3. 3 is not less than 2. So this is not a proper fraction either. So same problem we have here. The 2 is greater than the 1. So it's not a proper fraction. So we're going to have to divide. So just like any other type of long division, you put the denominator outside the division symbol. You put the rest inside the division symbol. And if the numerator and the denominator, largest power of s, were equal, like it is over here in this problem, we'll have one part that divides out. If the denominator is greater by 1 than the numerator, we'll have 2 parts that divide out. That's the case here. We'll have 2 parts. If this was an x cubed over something in s, we'd have 3 parts that divides out. So as we divide through here, firstly, we have to ask what times s gives us s squared, and it's s, so s times s plus 3 is s squared plus 3s. We subtract and get s. Bring down the 7. Does s go into s? It sure does. It goes in 1 time. 1 times s plus 3 is s plus 3. Subtract, and you get 4. Now, nothing times s will give us nothing times s will give us 4. Well, 4 over s gives us 4, but then we'd have s in the denominator. We don't want that. So at this point, we just stop and leave us with this. So in other words, this fraction is exactly equal to s plus 1 plus 4 over s plus 3. And we had 2 parts in the beginning because this was 1 part greater than s to the first. So with nothing more than this, we can actually solve to find its inverse transform. Looking up on our tables and pairs, s transforms to the derivative of the impulse. 1 transforms to an impulse. And 4 over s plus 3 transforms to 4 e to the minus 3t u of t. Do not forget that u of t at the end. And that's the second step.